Huntsbrook Incorporated provides a family of applications known as Little Apps. Little Apps are single-file programs that are not installed, but simply copied. The Divider Designer is a little app that creates dividers in a vector format. This is an overview of the Little App Box Divider Designer. Many of the interface controls are similar to the Shoebox Designer program, so you feel free to use the YouTube videos on that. What I'm going to do is start first by opening an existing project that we prepared. And what's different now is we added a 2 to the folders and also to the suffix. So Shoebox had LA1 and it didn't have any number in the data files or data folders. Here we add these to the 3 data folders. One folder is the PLT data for the laser cutter. Another is SVG for any vector program you might want to use with it, and you could also bring it into a program and convert it to a Illustrator file for the laser. We also have a art data file where we store information and artwork or templates for artwork that might be useful. We're going to go ahead and open the project. Select it, and on the screen we see a grid layout of the divider system, and we have 2 types of dividers. We have rectangular ones and we have finger slot dividers. Each type has a top version and a bottom version. The top version has the slots on the bottom, and the bottom version has the slots on the top. If you look at the grid, the continuous line representing the divider thickness from left to right is a top rectangular divider. The lines going vertically are what you'd see from a bottom rectangular divider. Okay, so we've opened the project that we want to work on. And now let's vary some of the control parameters and discuss what they are. Go under Edit, Divide Controls. There's several groups here we'll discuss, and there's buttons with question marks. The question marks open up text and graphical information to help explain what the particular group box is about. The first one is how many rows and columns you have in your divider structure. In this case, we designed a divider that's a 4x4 divider, and so there's 4 cells in this direction and 4 cells in the other direction. If you open up the text box, it has the descriptive, textual description of it, or you can look at the graphics. In this graphics, it's 2 columns by 3 rows, and the indices for the cells start at 0, then increment up along the horizontal, and in the vertical they start at the bottom at index 0 and go upward as you go up the grid. You can see that the top dividers are continuous all the way across. That's why they're on top. And the bot dividers are inserted from below, so they're occluded where the top ones are. The next group box is for the laser diameter. The program figures this in when it's doing its cutting. It gives you a lot more accuracy this way. Here our beam was about 11 thousandths of an inch. We explain how to measure this. We also have some videos on it in the box design, the shoebox design YouTube videos. We added in this program an additional control. It's lock vector segments into one And what that does on your dividers is it'll lock them into a single vector, and your laser will cut it in one continuous movement. If you unlock them, they're segmented in small parts. And what that allows you to do is in your laser interface software, you can custom design things like the finger slots. You don't have to just stay with this design. You can interchange shapes and whatnot. The cell parameters are basically the width of columns and the width of rows. And let's kind of look at this by example. If I go to a top, I can increment through, and you see over here this red border is showing me what cell what column I'm operating on. So if I wanted to change a width of, say, index 1 column, I will change this 2 to 1, go up, update values, and you can see all the cells in that column decreased in size. Now it turns out we want to have it 2.125 inches, so let me put that back. Now the other thing you can do here is you can do merging segments, and you can see we're cutting either on the left side or the right side of the socket, and you can use that for merging. We're not going to discuss that in any detail here. Now, if you move the bottom, you'll see the green border moves and shows you what cells you're operating on in terms of cell width. If you go to the help, we define what the parameters are. This is a bottom cell width. This is a top cell width. And these are the indices. Also, here's your merge cuts where they'll be placed if you need those. And you can always remove those when you're in the laser cutter software, because they're not connected to the rest of the vector. The controls have some global controls. They control the height of the various dividers, the height of the finger slots, corner radiuses, material thicknesses, and a slop value called socket gap that allows you to loosen up the sockets. Let's go into the help on this. And here you can see the socket thickness is actually the material thickness plus your socket gap. More than likely, you can just leave socket gap 0, but if it is too snug, you can add spacing there. The corner radiuses are simply the corners of the dividers to round them off so they're not sharp. For the finger slots, we have a parameter that you establish the depth that the finger slot goes to, and that's referred to as the top finger height. Here is the bot finger height, so you can control them separately if you want between top and bot components. You also control the maximum finger width, so your finger width doesn't get too big if the cells get extra wide. Now, if the cell gets narrow enough, what will happen is this will actually decrease with that, so you don't lose it and you don't have as much interference with these edges. You can push this to the limits, so if something looks funny on your screen out here, then it probably is. The outer dimensions are shown in this group. This will help you design your box that the divider goes into. The tops are 8.875 inches here, and the bots are 9 inches. Their heights are 2.25. 2.5. If we look at this, you can see this is the outer dimensions of your grid. And so you can use that for design purposes. Okay, we've cut our divider pieces. We have the tops, which are indicated by the sockets being on the bottom, and the bottoms where the sockets are on the top. Let's assemble the divider. I usually start with just two pieces, one top and one bottom, and then you put all the bottoms in. And then you finish off the tops. And there's the divider. Now, to make a pillow box, we have a liner and then an outside bottom and top of the box. So let's put this divider into the liner. The liner, the way we made it is we made it out of 1/8 inch material. And what we did is we used the box designer program to make it where the inside dimensions were based on the divider, plus we wanted some space up here to put some additional pieces on top of this in a manual. We also went ahead and sanded all the edges, because if you're going to get stuck on something, it's going to be burrs or little pieces of glue along the edges. The liner actually goes into the next section. Now, taking the outside dimensions of the liner, adding maybe 1 millimeter to it, or 40 thousandths of an inch, we designed another box with a thicker material, and that box has the inside dimensions based on the liner outside plus that millimeter. So the liner goes into it. So here you can see how the liner fits into this other material that's about 0.2 inches. It's important to measure because plywood labeled 1/4 inch can vary from 0.2 to almost 0.3 inches depending on how you get it. Then this was the base. Well, we made the base height, controlled it by the inside dimensions to not be all the way to the top. Well, we did another exactly the same base but a different height so that it would come down to this edge. And that became the top of the pillow box. Now we're not done yet though, because if you look at it, here's your classic laser finger joints. And we don't want it to really look like that. And so what we're going to do next is we're going to 1/4 round away all the edges, even on the bottom, to give it what we named it, a pillow box effect. So let's go do that. Okay, so we went and we 1/4 round the edges. This material is plywood. We're hoping to remove the black, and we did that. There is a thin line, it's kind of the edge of the soot that's in the finger joints. A few joints aren't done. That might be something you could adjust with the routing mechanism you use. What we're going to do is, the next step is we're going to use a stain. If you use a dark stain, of course, that'll suppress the contrast. We're going to use a lighter stain that matches the pieces in this grow game. We'll pitch that, grow the organic building game. We'll make the box for it. Now we also put in some finger slots, so it's more easier to grab, and I can show you that. Okay, so here's the finger slots. And with the idea of a pillow box, we did the bottom also. So it's rounded around all the edges where there were finger joints. And so next, what we're going to do is stain it. Okay, so we went ahead and we stained it and lacquered it. You can see that the contrast now along the finger joints are much less. They're still there, so you won't get rid of it completely. Looking at the bottom, we did notice a few are there, and what best I can evaluate is probably could correct that with adjusting the quarter round process. But overall, the pillow box came out pretty nice. It looks distinctly different than just a straight up laser box. And so that's our result.